Hi there, Mr. Sutton bringing you this lesson on properties of parallelograms. In this one, we will be figuring out missing sides and angles of parallelograms using these properties. Parallelograms belong to a wider class of polygons called quadrilaterals. Quadrilaterals have four sides and vertices. Now, parallelograms have some specific properties. Here are some of them. The big one that makes something a parallelogram, kind of the definition of a parallelogram, is that both pairs of opposite sides are parallel. So these two sides are parallel, these two sides are parallel. And feel free to mark up your diagram in your guided notes as we go. A second property that comes out of this parallel nature is that both pairs of opposite sides are going to be congruent. They're going to have the same length. Because these sides are parallel, that means the distance between the two sides is always going to be the same. So that means these two sides are going to be congruent, and these two sides have to be the same distance as well. In addition to congruent opposite sides, parallelograms also have congruent opposite angles. So for example, A and C are congruent, and also B and D. As a fourth property, consecutive angles in a parallelogram are supplementary. So for example, if angle A is some angle, that means that angle B, the consecutive angle, the angle right next to it, is going to be whatever 100 minus that first angle is. These two angles are going to add up to 180. And this angle and this angle add up to 180, and this angle and this angle and this angle, they all add up to 180. And this is actually an offshoot of transversal parallel properties. Angles A and B, for example, those are consecutive interior angles on two parallel lines. The last property of parallelograms is that their diagonals bisect each other. So if we draw two diagonals in here, we know that DE and BE are going to be the same, and we also know that this diagonal is bisecting this other diagonal, making AE and CE the same length. So the nice thing about having all these properties of parallelograms is that if you have a parallelogram and you only know a few of the sides and angles, you can find all the other ones. Pause the video and see if you can find all the missing sides and angles in this diagram. All right, let's see how we did. So one property we can use is that opposite sides are congruent. So let's just set opposite sides equal to each other. We know HE has to be the same as FG, so 9. And we know that FE and GH are both the same, so those both have to be 15. Now for the angles, we know opposite angles are equal to each other in a parallelogram. So that means angle H has to be 80 degrees, just like angle F. And G and E, both of those angles, we know that consecutive angles are supplementary, so we just have to subtract from 180 to get G and E. So that would be 180 minus 80, giving us 100 degrees for those. Here's another parallelogram sides and angles problem. This one's got some x's in it. Pause the video and try this one out. All right, let's start with the angles. Now again, opposite angles are going to be congruent, so we know that angle J has to also be 56 degrees. You might have been tempted to say 2x equals 56. We'll get there later. We're not there yet. We just need the angle. All right, how about K and M? Well, those are going to be supplementary with 56, so 180 minus 56 is going to give us 124 degrees for both of those. How about the sides? Now we need to figure out what the value of x is. So we'll just use the x from this angle in these side expressions here. So we can say 2x equals 56. So now we can solve for x. X is going to be 28. And 28 is just a number that we're going to plug in to find the value of all these different sides. So for jk and also for ml, we just have to do 28 plus 3, x plus 3. That's 31. And for KL and JM, it's going to be 2 times 28 minus 8. So that's 56 minus 8, 48. Here's a problem with some diagonals. If the diagonals AC and DB are 10 and 14 millimeters respectively, find the segment lengths. In other words, find the lengths of AE, EC, DE, and EB. Pause the video and give it a shot. So the property here is that diagonals bisect each other. So that means each segment is going to be half of the diagonal that it's part of. So for example, for AE and CE, those are just going to be half of whatever AC was, which was 10. So those are both going to be 5 millimeters. And then DE and BE, those are both half of 14, so those will both be 7 millimeters. For this last problem, we're going to up the difficulty a little bit and not draw the parallelogram for you. In a parallelogram PQRS, measure of angle R is 24 degrees more than measure of angle S. Sketch the parallelogram and then find the measure of each interior angle. Pause the video, give it a shot. Now the key to this one is drawing things in the right order. When you draw any polygon, you have to make the vertices go in the same order that the name has. So it has to go P, then Q, then R, then S. So here is one such parallelogram. Notice P, Q, R, S goes in that order. We're not skipping from P to R or any craziness like that. Now let's label each of these with an expression that can help us solve this problem. They told us that R was 24 more than S. We don't know what S is at all. So let's make S X. And if R is 24 more than that, we can write R as X plus 24. Now we know that consecutive angles are supplementary. So we can say X plus 24 equals 180. So then that's 2X plus 24 equals 180. Subtracting 24, we get 156. And then that's going to be 78 for the value of X. Now this doesn't tell us all the angles. It does tell us S and the opposite angle, Q. Those are both actually going to be 78 degrees. If we want to figure out R and P, we just have to do then 78 plus 24, which comes out to 102. Now just as a double checking measure here, these two angles, whatever they are, better add up to 180. So let's double check. 78 plus 102? Yep, that adds up to 180. This concludes our lesson on parallelograms. Until next time, this is Mr. Sutton signing off.